out there, and welcome to Peter's online tutor. Today we shall be looking at mathematics. Now, if you follow my initial video where I talked about how to find the coil of a vector field, okay, I actually derived the method that can be used to solve questions relating to what? Finding the coil of a vector field. All right. Now we are going to be applying that particular formula that we derived to solve this particular question. All right. So the question reads: find the coil of the vector field f of x, y, z equals y cubed I plus xyj minus zk. All right. So how do we solve this question? Let us go. Now, the first step here is to bring back the formula that we have already derived. Okay, so let's have the formula now. Remember that for coil of a vector field, all right, x, y, z. Okay, this is the formula that we derived in our first video on how to solve the coil of a vector field. Now, this is a question. So, how do we go about this? Our f1 is y cubed. Our f2 is xy. Our f3 is minus what? Minus z. So let me quickly write it out here. So f as a function of x, y, z equals our f1 now, okay, is y cubed. Okay, f1 is what? Is y cubed. Then our f2 is xy. And then our f3 here is minus what? Minus z. So if you know this now, we can actually slot them in here, all right? And then we'll get our answer, all right? Good. So from here, we are having the coil of the vector field x, y, z equals. Now, look at this. The partial derivative of f3 with respect to what? To y, okay? Now, from here, now we're having our f3 as what? As minus what? Minus z. So we can still have it like this, bracket open. Now, our f3 is what? Is minus z. So we can actually put it as minus z. Are you following? Good. Then, now the partial derivative of f2 with respect to z. Now, our f2 is what? Is xy. So we can actually write like this. Our f2 here is xy. Bracket close. Is understood? Good. So we are having this as what? As I. Don't forget. All right. So minus. Now let's come back here. Our f3 here is minus z. So remember to put your minus z. Okay. Don't forget. Minus our f1 here, okay, is given to us as y cubed. So put a y cubed, don't forget, and that is what? That is j. Is that clear? Then plus brackets open. All right. Now we are going to be writing. Okay, let me write the. Now remember that our f2 here is what? What is our f2? Our f2 is xy. So let's put xy. Is that clear? Then minus. Now our f1 is y cubed. Y cubed. That is k. Okay? Remember that what we are still looking for the coil of the vector field. So from here now, will be the coil of the vector field is equal to. Now, watch this. Now, I'm looking for the partial derivative, okay, of this particular function with respect to what? To y. But there is z. So that means here is 0. Don't forget. So I'm having 0. Now, also, I'm looking for the partial derivative of this particular function with respect to what? To z. But what I'm looking for the partial derivative is actually what? Xy. So it's different from what I'm having here. So here too is what? Is 0. I. Is that clear? Then minus Now, I'm also looking for the partial derivative of this function with respect to what? To x. But there is what? There is z. So obviously here 2 is 0. All right. Now the same thing applies here. The partial derivative of this function with respect to z, here is what? Y cubed. So I'm having 0 also. Okay. Right? Then plus. Now the same thing applies here, but if you check here now, I want to find the partial derivative of this function with respect to x. All right, and then there's x, y here. All right, so y here is my constant. So when I look for the partial derivative of xy with respect to x now, I'll be getting what? I'll be getting y. Don't forget. All right, good. Minus. Now, looking for the partial derivative of this function with respect to what? To y. Here is y cubed. So the partial derivative of this now will be 3y squared. All right? And that is what? That is k. Okay? So here is 0, here is 0. So at the end of the day now, my answer becomes what? Y minus 3y squared. Bracket open, bracket close, k. Am I communicating? Good. This is what the answer to the what? The coil of the vector field. And the direction is what? Is k. Thank you.